Okay, so now that you've read your booklet and you've watched the video explaining volumes of revolution, let's actually do an example. So this is example 4.1 in your further applications booklet. So the first thing I would always do is I would always sketch my graph. So this is a cubic, fairly simple graph to sketch. I am going to be determining the volume when I rotate from 0, 0 to where X is 4. I don't actually really need that point on the graph. I'm going to go ahead and put it on there. So I'm going to be revolving this region here that I've highlighted in pink. I'm going to be revolving it about the x-axis. And so the formula that you see on the previous page is pi, which everyone forgets the pi, from the lower boundary of a to b, y squared dx. And so y squared is really, that's your radius squared. So think about the volume, for instance, of a circle, which is a two-dimensional object, is pi r squared. If we were to integrate that, that would become the volume of a sphere. So this y squared is really defined by x cubed. So that purple would be the radius when we revolve this pink region around the x-axis. So therefore, we're integrating from an x value of 0 to an x value of 4. Y is actually just the height, so that's defined by x cubed, and it's squared since it's a radius. Usually the integration is fairly straightforward, and that we're just integrating x to the 6, which gives us, when we integrate x to the 7 on 7, evaluated from 0 to 4. So that's 4 to the 7th on 7 times pi. And if we evaluate when x is 0, that's cancels that, that just drops out. And I don't know what 4 to the 7th is. That is very large, 16,384 pi on 7. And that would be the volume of this solid, which would kind of look like the bell of perhaps a trumpet when we were to rotate this and create a three-dimensional object. So what I'd like you to do now is I would like you to give the next few problems a go. Examples 4.2 and 4.3 on page 48 and 49 of your booklet, and upload those to Canvas. Hopefully you've recognized that I've adjusted what the homework is. I've pulled out problems that you can practice that are straightforward, that are revolved about the x-axis and only the x-axis. Doesn't apply what the video called the washer method. We'll address that tomorrow. And then if you keep reading down on the Canvas page, you'll see that tomorrow in the double that I'll explain part 2 when we revolve about the y-axis and this thing called the washer method, which your textbooks won't use that word washer. And I've also segregated homework that applies to revolving about the y-axis, and then there'll be a Q&A video conference as well during the double. Good luck, and let me know if you get stuck.